All right, 3-9 Z-scores. Give you a little bit of background. Suppose I have a 4th period trig class, a 6th period trig class, and a 7th period trig class. Ironically, I do. And you'll notice that the averages were 84, 79, and 85. And standard deviations 3, 6, and 2. 6th period had a fire drill and lost 10 minutes of class time. But evil Mr. Staley would not give them any time in class, any additional time. So their averages were lower. As you can see, considerably lower than 4th or 7th. So people might argue, hey, that's not fair. You didn't give us enough time to finish it. So the question becomes, how could we compare scores to each other? How does one person in 6th period compare to someone in 4th period, compared to someone in 7th period? Well, a transformation of the data, excuse me for being tired, a transformation in the data occurs by taking a data value, subtracting its average, and dividing by its standard deviation. Now, when you do this, you will find the data value's distance away from the average, and it could be a positive distance if it was above the average, or it could be a negative distance if it was below the average. If it was exactly equal to the average, then the distance would be 0. Okay, now you might want to think about that for a second. So, dividing by the number of standard deviations means that you are trying to take that distance and convert it into a unit of measurement. Well, what's the unit of measurement? Well, Z-scores. That's what we're talking about, Z-scores. Sorry, a little bit of German there. Okay, the number of standard deviations, that's what a Z-score represents. The number of standard deviations. As I said, it could be above the mean, or it could be below the mean. Now, the Z-score of 0 itself, that corresponds to the actual average. 1, 2, and 3 are 1 standard deviation above the average, 2 standard deviations above the average, 3 standard deviations above the average. Or 1, 2, 3 below the average, with the negative values. Let's take a look at a couple questions. Once again, sorry for yawning. I'm recording this at midnight. I'm sorry, I'm not. That's not really true. It's 2:41 in the afternoon. Okay, boy, I lost my place. Aha! Here is a chart from the book. I want you to get those numbers written down there. We got Fern, Rick, and their physics and math tests, averages and standard deviations for the classes. Okay. Question 16 in the book. If I can get my pen to write. Tra-la-la. There we go. Okay. Now we're good. How many standard deviations above the mean is Fern's score on the physics test? Well, Fern scored on the physics test scored an 82. The average on the physics test was 58, so she scored well above the average. The standard deviation was 6.9. So Fern's Z-score, here we got 82 minus 58 divided by 6.9. Fern scored approximately a 3.48. That means she is 3.48 standard deviations above the average. That is awesome. Now you might look at it and say an 82 is not a good it's not a good score, but perhaps that test needs to be curved. But in relationship to everybody else, she was way above the average. Okay, and Question 17 in the book says, on which test did Rick do better compared to the others? I want you to, that phrase, compared to the others. As soon as you see that phrase, you should be thinking about z-scores compared to the others, because that is a critical phrase for telling you that you need to be dealing in z-scores. See, Rick scored 68 on both tests. So let's see here. Find out the z-scores and then tell me which one he did did better on compared to the others. Okay, so find those z-scores. Question 18. Sue had a 58 on the physics test. She scored equally well. Scored equally well. That means she had an equal z-score. So she got a 58 on the physics test, but her z-score was equal. So a little cross multiplication, you should be able to figure that one out. So tell me what she got on her test. What was her actual score? 19, it says Angela had the same raw score, and she performed equally well. Ooh, performed equally well, or scored equally well. So this means same x value, and this means, whoa, can't see that, can you? Sorry, as you can tell, I wasn't paying much attention. So in question 19, it says same raw score, and then scored equally well. And same raw score would mean same x value, and scored equally well means same z-score. So Angela, we get minus 58 over 6.9. And this is her z-score for the physics. And this is her z-score for the math. And because it says she scored equally well, you can notice that I used the same variable on both of these. That means she got the same raw score. But same z-score means that this z-score over here equals this z-score over there. Okay, so what do? How do you solve a proportion? You better cross multiply. So I will let you figure out what the rest of that one is. Okay, let's move on to section 4.1. Section 4.1 begins a very, very large chapter. There are 10 sections in this chapter. We will split it into 2 chapter tests, one of 50 points, or each one of 50 points. So you'll have sections 1 through 5 in a test, and then 6 through 10 in a test. Once again, sorry for yawning. We need to start out understanding measurements of angles and rotations. We're going to start off with something simple. Knowing and understanding how angles measured in degrees will work. You are very familiar with this. You know that there are 360 degrees in a circle. Well, 0 degrees starts out on the far right of of the axes. A positive rotation will head in the counterclockwise. And a negative rotation will move in the clockwise manner. So if it says draw a 45-degree angle rotation, of course we start here. This is called my initial side of my angle. And a 90 would be straight up like this, so we want half of that. This would be what we call the terminal side of my angle. And I draw an arrow indicating which way that the rotation is going. And that is a rotation of 45 degrees. So what does negative 240 look like? Well, keep in mind that this is 90, and this is 180, and another 90 makes 270. And then back to the original would be 360. And as you can tell from the next example, 450 degrees, you're going to keep going around the circle even farther than a full revolution. So negative 240. This is negative 90, negative 180, and then after that would be another 60 degrees. So we start here with our initial, negative 90, negative 180, and then how much after that? Well, it's about 60 degrees, right? After that. So it's going to be up here somewhere. But since it's in the negative rotation, you need to indicate that on the graph that you're going in that direction. 450, well, we start here. Now that's 90, 180, 270, back to 360. Another 90 degrees added onto 360. So we went around the circle once and then stopped there. Trying to find a picture for you in the book that I think is important. Show you that in a little bit. Okay, so what's a radian measure? We talked about this with you last year briefly at the end of the year. Hopefully this comes back to you, but 180 degrees is the equivalent of pi radians. So if this is 0 and this is 180 and this is 90, that's half of 180, then this would be half of pi. We'll call that 1 pi over 2. And this would be 270. That would be 1 pi over 2, 2 pi over 2, 3 pi over 2. Yes, I know, 2 pi over 2 reduces to just pi. 360, back to the beginning, would be 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is the same thing as 2 pi. So here's an important fact for you. 360 degrees is equal to 1 revolution, which is also the equivalent of 2 pi radians. We do simplify this one right here a little bit, right? Because we can see that you could take a 2 out of both of those numbers. So we could say that 180 degrees is equal to pi radians. And that's more often what you will be using for degrees to radians conversions. So how do you change 30 degrees into its radian counterpart? Well, perhaps you've seen unit conversions. The one that you want to keep stays on the top, and the one that you want to get rid of is in the bottom. I chose pi and 180 because they are equivalent measures. I want the radian measures to stay, but I see that the degree units will cancel out. leaving me 30 pi over 180. It is your job to reduce it. No, you will not have a calculator. You will need to reduce that on your own, using your own brain. So, we could divide, right, the top and the bottom by 10. And then we could continue to divide by 3. So we end up with pi over 6 radians. What about 3 pi over 4 to revolutions? 3 pi over 4 revolutions, and we want it to be converted to radians. Oh, no, sorry. That's in radians. Cancel that out. We want to get rid of radians. We want to end up in revolutions. So 1 revolution is 2 pi radians. Okay? Anything cancel out? Sure, the radian units cancel out. The pi's cancel out. We have 3 times 1 on the top and 8, 4 times 2 on the bottom. So 3/8 of a revolution. Change 4/3 of a revolution to degrees. Okay? 4/3 of a revolution to degrees. We want to end up with degrees. So 1 revolution is 360 degrees. The revolution units will cancel. Now we need 4 times 360 divided by 3. Well, 3 goes into 360. Let's see, 1, 2, 0. So this is 4 times 120, which is 480 degrees. Fairly hot angle, I might add. Okay, you might burn yourself on that one. I'm going to give you questions like this. Fill in this chart. I'll give you a degree measure and I expect you to change it to radians and revolutions. Or a radian and expect you to change it to degrees and revolutions. Or a revolution, you expect you to change it to degrees and radians. If I were you, I would always start with the one I'm given so that I don't make a mistake on the first one and then carry it over to the second one. Always start. So when you want to go from 210 to radians, start with 210. If you want to go from 210 to revolutions, then start with the 210. Don't use this answer to get over to here. I mean, you could use it to double check, but I wouldn't want to use that solely because you might make a mistake, and then I don't want you to make 2 mistakes. Okay, so fill in this chart. You've got 210 degrees, negative 2 pi over 3, and 5/8 of a revolution. And I'll see what your answers are in class.